So the next part we will discuss about the RF module. Now, as I mentioned just now, the RF divided into two sections, which is you contain of RFU and you contain of the RRU as well. So as I mentioned, the RFU is the one that you put together with the cabinet, which is the macro type, whereas the RRU on the other hand is the distributed type in which they are separated from the BBU. So we got different type of RFU depending on the mod. For example, we got for multi-mod, we got for 2G mod, and then we got for pure 3G mod. So in case, let's say for example, if the RF module that you want to use support multi-mod, the RFU that you can use is MRFU. So MRFU, the M generally stands for multi. Okay, so we got MRFU, MRFU version D, MRFU version E. On the other hand, if you are using RRU, the version, if you notice, RRU is slightly different from the RFU. They use number to represent the mod. So normally, the RRU start with the 39 something something, for example 3908, 3926, start with 39, normally it's support multi-mod, but it's not always. On the other hand, for 2G, if you are using RFU, the RF that support 2G is DRFU and GRFU. The one that support RRU for 2G is RRU 3004 and RRU 3008. And then if your RFU only support 3G, so here is the example, WRFU, W generally stands for WCDMA. And if you are using RRU, normally the RRU we start with 38 something something, it's the one that support the 3G, but it's not always. So if you see here, RRU 3801, 3824, 3826. Here is the example of one of the RFU board. So if you notice here, here is a GRFU. For all the RFU board, the appearance is exactly the same, whether it is 2G, 3G or multi-mod. The appearance, the number of port is exactly the same. The only difference is the label at this position. So this position, if it is GRFU, they will label as GRFU. If it is W, then they will label as WRFU and MRFU. So what happened is that for each of the RFU board, the label is different here and the capacity that they support is also slightly different. So notice that this one is a RFU board. You got a 2 big port here. What is the function of these 2 big port? These 2 big port is connect to the antenna. So as you see the label here, the antenna here, we got 2 antenna, which means that if you look at the first antenna, they got label here as TX/RX. If you see the label inside is TX/RX, which means that this antenna port, they can transmit and receive the signal at the same time. So if you look at the upper position here, if you see the label is just RX, which means that this port only can receive signal, they cannot send out the signal. So in another word, this 2 port is the antenna port. And notice that at these 2 position here, you see you got a CPRI0 and CPRI1. So what is the function of CPRI0 and CPRI1? This is the port that connects to your BBU, which is your BBP board. So here is the bigger version of the board. If you notice, you got 2 big ports here, which is the antenna port. Okay, so you got antenna, first antenna and second antenna. The first antenna support, transmit and receive. Second one is just receive. And then you got the CPRI port, which is located at this position. So CPRI0 and CPRI1. So normally if we connect the BBU to the RF unit, we will use the CPRI0 at this position. So what for we need to have another CPRI1? So this one is for future cascading purpose. And then we also got these 2 ports, RX and then RX, in and out. What is the function of these 2 ports? The function of these 2 ports is for inter-RF connection. So in case both of the RF you are using to connect to the same antenna, you need to use these 2 connect to another RFU board. And then the last one, you got power port, which they get the power supply from the DCDU. And then you got monitoring port as well. So that one is GRFU. So notice that the WRFU, the appearance is exactly the same like GRFU. The only difference is the label here. So this one is the WRFU. And each of the RFU board got their own band power to support. If you notice the frequency band here, for WRFU, they support 2100 and 850 megahertz. So each of the RFU board can support multiple band. However, notice that one thing, although they can support multiple band, at one time you choose one only, which means that this board can support 2100 and 850. But once I choose it support 2100, they no longer can support the 850. And then what is meant by here? Maximum output power. Each of the antenna port here, they got their own maximum output power. Let's say, for example, if the output power is 80, which means that one port, the maximum transmission power is 80 watts only. And each of the board, they also got the maximum number of carrier they can support. Let's say, for example, for this WRFU, they can support a maximum of 4 carrier. And then if you use an optimized WRFU board, they can support 4 carrier inside as well. So different type of board, they can support different amount of carrier. So this one is to tell you the LED. So notice that at this position, you got the LED indicator, which indicates whether your RFU board is normal or abnormal. So if you see the indicator at this position, you can predict whether your RFU board is normal or abnormal. So this slide is actually show you how your RFU board is connected to the antenna. So notice that here is to show you 3 different scenarios. So the first case is if they support 4-way receive, which means that the antenna, you want them to receive in 4 ports. So notice that these two, 1 receive, 2 receive, 3 receive, 4 receive. So total, this antenna, they can receive 4-way receive diversity. How about the next one, transmit diversity, which means that they transmit using more than 1 port. So you notice that this antenna is connected to these 2 different antenna. This port, both of the port can transmit. So this is meant by the transmit diversity. So the last one is 2 times 2 MIMO, which means that they can 2 transmit and 2 receive at the same time. So you notice here, connected to this antenna, this one is 1 transmit, 1 receive. So they connected to 2, so it's total of 2 transmit, 2 receive. And notice that all the RFU is connected to BBU directly using the BBP board. So the next board is RFU board. So this one is MRFU, which support multi, which means 2G, 3G together. So notice that the appearance is exactly the same. The only difference is the label at this position, the output power, and the capacity they can support. So this one is to show you the function of each of the port, which is similar like the WRFU. Now, after discussing the RFU, how about the RRU? Now, notice that the appearance of the RRU is different from the RFU. Now, the RRU, this one is the hardware. Notice that the hardware here, this one is the one that facing downwards at the tower. So normally we put RRU up at the tower. This part is the part that is facing downwards. And the one that facing downwards, notice that you got 2 ports here. The function of these 2 ports is connect directly to the antenna. So antenna here, if you notice, here is transmit receive. This one is only receive. So it's similar like the RFU. It's just the position is slightly different. This one is located at the down position. How about the port that connected to the BBU? The port that connected to the BBU to the RF is located at this position. So notice that at this position, you got these 2 ports, CPRI port. So the function of this CPRI port is connect directly to the BBU. So the BBU BBP board is connected directly to here. And then notice that this one is the power supply, okay, power supply board. And then the last one at this position, this one is the indicator to indicate whether your RRU is working normally or not. So here is to show you the technical specification. So each of the RRU, they got their own band to support. Notice that for RRU 3804, they support 2100 band and 1900. So at one time, you can only choose one. And this one is to tell you the capacity they can support. So for RRU 3804, they can support a maximum of 4 carrier. And the example that's shown here, output power, is to show you that if you use 1 carrier, what is the output power for 1 carrier and so on. notice that the more carrier that you use, the power that's supported by each of the carrier will be lower and lower. And this slide is actually to show you the connections between the RRU to the BBU and to the antenna. So notice that the side here is the one that connects to the CPRI, the one that connects to your BBU, and then the down one here is the one that connects to your antenna. And how we install the RRU. Generally at one tower, we will cover 3 different sectors. Traditionally, when we install the RRU, we will install at this position. So which means that one RRU is facing one direction. But if you are using our blade RRU, you can install all the 3 different sectors together. By using this configuration, you can actually save a lot of space. And you see here, the box reduces the wind resistance and it is easier for you to install. You no need to adjust for 3 different angles. You can actually install it all together. And it also supports flexible configuration, which means that for one RRU, you can choose to support 2G and 3G together. However, it must be from the same band. So here is the example of scenario. Notice that this RRU, they support the band 900. Let's say, for example, if I want to increase one more band, so you can increase here, band 1800. And then if you want to increase one more band, you can increase the band here, 800. So always remember, one RRU can only support one band at one time. That part is about the RF unit. The next part, we will go for the power module. So where do the BBU get the power? Where the RF get the power? So as I mentioned just now, all the BBU and RF, they get the power from this unit, which is the DCDU, okay, the direct current distribution unit. So notice that for all the DCDU, you got always 2 input and 10 output. 2 input, one is active and standby. And then how come you got 10 output? Depends. So if you got 10 output, which means that you got 6 RFU. So which means that they supply the power to 6 RFU. You use up 6 power output, 1 to BBU, 1 to the fan, which means a total of 8 output is already occupied. End up, you still got extra 2. So the extra 2 output power is reserved for extra equipment. And notice that the example that illustrated here is that the power supply, if it is negative 48 volt. Let's say, for example, if your power is not negative 48 volt, it is positive 24 volt. If you're using positive 24 volt DC, then you need to have a PSU. The function of PSU is to convert positive 24 to negative 48, then only they channel the power to the DCDU. So in case you are using the AC power, let's say for example positive 110 volt or positive 220 volt AC power, then inside your power subsystem you must have the PMU and PSU. So what is the function of PSU? The power supply unit is to convert the AC power to negative 48 volt DC power. And why you need to have a PMU? The name itself, PMU, power monitoring unit, is actually to monitor the power. So after they convert the power, they send the power to DCDU. DCDU will distribute the power to the remaining devices. This is how the DCDU looks like. Notice that you got 2 input and a total of 10 output. And the 10 output here, if you notice this diagram, they have already labeled for you. The 0 and 5 here, it's supply the power to the RF, and then you got the power supply to the fan, to the BBU, and 2 extra, reserved for extra transmission equipment. PSU is the power converter. The power converter normally we put at this position inside your cabinet. In case you are using the AC power, you require to put an extra unit of PMU inside. The last part is the fan and the SLPU unit. Now, in our cabinet, normally we contain of the fan unit. So what is the fan unit? Is actually for cooling. So if you look at the slide, it provides ventilation and the cooling for the cabinet. It also provides the functions of monitoring the temperature. Let's say, for example, if they detect inside the cabinet the temperature is very high, they will adjust the speed of the fan become faster. And if, let's say, for example, after cooling, the cabinet is not so hot, what happens is that they will adjust the fan to become lower speed. And the last one is the SLPU unit. As I mentioned just now, this unit, SLPU, Signal, Lightning and Protection Unit, is only applicable if you put your cabinet outdoor. What is the function of SLPU is actually protect your signal during the thunderstorm, as the name has suggested, Signal, Lightning, Protection Unit. So this Signal, Lightning, Protection Unit, if you notice, there is total of 4 slots inside. So which means that inside this SLPU, you can put a maximum of 4 boards. So what type of board you put it inside depends on what type of signal you want to protect. Let's say, for example, you can put a UELP board. What is the function of this board is actually to protect the signaling in case you are using E1T1 port. So let's say the E1T1 port, normally we connect E1T1 port and directly connect to the transmission equipment. However, if you're using SLPU, the E1T1 is connected to the SLPU, and from the SLPU, it is connected to the transmission equipment, which means that you got one more extra intermediate. What is the function of this extra intermediate is to protect your signal for the E1T1 during the lightning. The last board will be the UFLP board. So what is the function of this board is to protect the signaling for the FE transmission. Let's say, for example, if you are using FE transmission, normally the FE will directly connected to the transmission equipment. However, if you put outdoor, normally the FE will connect it to your UFLP. From the UFLP, we connect to your transmission equipment. Thanks for watching.